In 2009, a team of NASA physicists ran into a problem they couldn't solve with modern technology. To calculate the orbital trajectories of planets and predict historical eclipses, they needed to know the exact speed of the Earth's rotation thousands of years ago. No satellite could measure that. No supercomputer could simulate it. The answer, it turned out, was buried in a 2,700-year-old diary entry, written in classical Chinese by an astronomer who knew that if he got the math wrong, his emperor would have him killed. This is the story of how ancient China turned the sky into the most dangerous science project in human history. The year is 2137 BCE. You are an imperial astronomer standing in the court of a Chinese emperor. The midday sun begins to vanish. The sky darkens to twilight. Birds fall silent. A ghostly halo appears where the sun used to be. Today we call this a total solar eclipse. But in ancient China, this was not a scientific event. This was a verdict from the gods. To understand why, you need to understand the most powerful political concept in Chinese history: the mandate of heaven. Originating during the Zhou dynasty around 1046 BCE, this doctrine held that the emperor was the literal son of heaven, the cosmic bridge between the mortal realm and the divine. If the emperor ruled justly, the harvests came. If he was corrupt, heaven would withdraw its mandate. And how did heaven announce its displeasure? Through comets, floods, and above all, unpredicted solar eclipses. An eclipse that the court astronomers failed to foresee was the ultimate omen of doom. It told every general and every rebel army in the empire that the emperor had lost divine favor. Predicting eclipses was not academic curiosity, it was national security. So the state built what historians call the celestial bureaucracy, a permanent, highly organized corps of astronomers working around the clock, tracking every movement in the sky. And here is the detail that surprises most people. Studying the stars in private was illegal. Ordinary citizens caught observing the heavens could be thrown into the stockade or executed. The sky was state property. Astronomy was classified intelligence. We have records from an ancient text called the Shu Jing that tell the story of two royal astronomers named Shi and Ho. Around 2137 BCE, they supposedly got drunk and missed the warning signs of an impending solar eclipse. Their punishment was immediate: execution by beheading. When failure means losing your head, you develop extraordinary precision very quickly. But how do you map the cosmos without a telescope? You don't look up. You look down into the mechanics of water and metal. In 117 CE, a polymath named Zhang Heng changed everything. Zhang Heng was not merely an astronomer. He was an engineer, a mathematician, a poet, and quite possibly the most underrated scientific mind of the ancient world. He proposed what was called the Hun Tian, or sphere heavens theory. The sky was like an eggshell, and the earth was like the yoke suspended inside it. To prove this model and to track the heavens mechanically, he built the Hunyi, an armillary sphere. But this was not a static classroom model. Zhang Heng connected it to an inflow clepsydra, a precision water clock, creating one of the earliest known water-powered astronomical instruments. Dripping water provided a constant hydraulic head that turned a water wheel. Through a complex system of gear assemblies and pulleys, the massive bronze rings rotated in synchronization with the actual sky. By looking through a hollow bronze sighting tube called a Wang Tong, astronomers could align stars and planets against precise coordinate rings, calibrated to the North Pole and the lunar mansions. For context, Europe would not produce anything approaching this level of automated mechanical precision for centuries. Chinese astronomers were sitting in imperial courtyards, watching the cosmos rotate on a bronze axis driven by the steady drip of water. A machine, however, is only as good as the data you feed it, and the data these astronomers collected was staggering. We know this because of a discovery made at the edge of the Gobi Desert. In 1907, a British nationalized explorer named Aurel Stein arrived at the Mogao Caves near Dunhuang, an astonishing complex of Buddhist temples carved into a sandstone cliff along the ancient Silk Road. Inside a hidden chamber that had been sealed shut around the year 1000 AD, he found a hoard of 40,000 manuscripts preserved perfectly by the dry desert air. Among the religious texts was something no one expected: a roll of thin mulberry paper drawn with ink. It was the Dunhuang Star Chart, dating to the early Tang dynasty between 649 and 684 CE. This is the oldest complete preserved star atlas from any civilization on Earth. It displays the full sky visible from the northern hemisphere, containing 1,339 individual stars organized into 257 asterisms. But this was far more than a pretty drawing. The astronomers had used a sophisticated planar projection to flatten the dome of the sky onto paper. 12 hour-angle maps in a quasi-cylindrical projection, plus one circumpolar map in an azimuthal projection. This is strikingly similar to the Mercator projection used in modern world maps, except the Chinese did it hundreds of years before Gerardus Mercator was born. The chart was essentially a portable astronomical database, likely used by the director of the Astrological Service. It combined precise star positions with astrological predictions based on the movement of Jupiter. For the brightest stars, the positional accuracy falls within 1.5 to 4 degrees. This was not rough guesswork. This was systematic, institutional science. Drawing stars on paper and spinning bronze globes, though, still was not enough for the emperors. They demanded something grander, something that would mechanize the heartbeat of the universe itself. The year is 1092 AD. The Song dynasty capital of Kaifeng is one of the largest and most sophisticated cities on Earth. Here, an astronomer, pharmacologist, and mechanical genius named Su Song receives an imperial commission: build the ultimate astronomical device. What he created was the Shui Yun Yi Xiang Tai, the cosmic engine. Picture a wooden tower nearly 40 feet tall. Inside, a massive water-powered wheel. But Su Song had to solve a fundamental engineering problem. How do you make a wheel turn at the exact, constant pace needed to match the slow rotation of the Earth? His solution was a water escapement mechanism, a device that regulated the flow of water so that the wheel advanced in precise mechanical steps rather than spinning freely. At the top of the tower sat an armillary sphere for tracking stars. Below it, a celestial globe that rotated automatically. And on the front of the structure, multiple floors of mechanical automatons. Wooden figures holding gongs, bells, and drums, popping out of doors to mark the hours, driven by an intricate labyrinth of over 400 gear parts. To put this in perspective, Europe would not see the invention of the mechanical clock for another 200 years. Su Song had built a gigantic, automated, ticking astronomical computer that simultaneously told the time and mapped the coordinates of the heavens. The invading Jin army eventually destroyed the original tower. But Su Song did something incredibly rare for his era. He published his blueprints. His treatise, Essentials of a New Method for Mechanizing the Rotation of an Armillary Sphere, preserved the engineering for future generations. This obsession with documentation was not an accident. It was the defining feature of Chinese astronomy. They were not just observing the sky for their own generation. They were building an unbroken chain of recorded data stretching across 4 millennia. And it is exactly this obsession that brings us back to where we started. Remember those NASA physicists? Their problem was a quantity called delta T. Over thousands of years, the friction from ocean tides gradually slows the rotation of the Earth. Because the Earth spins slower today than it did in antiquity, our modern atomic clocks slowly drift out of alignment with the true historical positions of the planets. To calculate ancient eclipses or plot orbital trajectories deep into the past, scientists need to know exactly how fast the Earth was spinning at specific points in history. You cannot measure the spin of the Earth 3,000 years ago with modern instruments, but you can measure it with the records of astronomers who were terrified of losing their heads. In the ancient Chinese state of Lu, the birthplace of Confucius, court astronomers kept relentless, meticulous records. On July 17, 709 BCE, they witnessed a total solar eclipse. They did not simply note the date. They recorded that the eclipsed sun appeared, and I quote, completely yellow above and below. When modern researchers translated this passage, they realized they were reading the earliest datable written description of the solar corona, the sun's superheated outer atmosphere, visible only during totality. Because the path of a total eclipse is extremely narrow, knowing the exact city where this was observed and the exact visual conditions allowed modern physicists to reverse engineer the mathematics. By pinpointing the coordinates of the Lu Duchy court, researchers used this single 2,700-year-old diary entry to calculate the precise rate of the Earth's rotation in 709 BCE. Today, the equations NASA uses to model the deep time mechanics of our solar system are fundamentally calibrated by the panicked brushstrokes of ancient Chinese astronomers who believed that a missed eclipse meant the end of their dynasty and their lives. Think about that astronomer in 2137 BCE, the one standing in the emperor's court as the sun went dark. He did not have satellites. He did not have supercomputers. He had water, bronze, ink, and the knowledge that failure was death. That terror drove an empire to build a scientific infrastructure so precise, so meticulously documented, that nearly 3,000 years later, it is still woven into the mathematics guiding spacecraft through the solar system. They turned the sky into a clock and a map, and the clock is still ticking. This has been Silk Road Annals. If this story changed the way you see the ancient world, subscribe and hit the bell. There are buried histories along the Silk Road that no one is telling, and we are only getting started.